Good evening. It's June the 1st today, and it's a special day. We are going to finalize all our challenges for the Microsoft Build Cloud Skills Challenge. And let's start the show. Welcome back to my 28th module of 28 from the Microsoft Build Cloud Skill Challenge. That's a challenge that they introduced at the Build conference, I think 2 weeks ago maybe. And what you need to do is perform a couple of modules to learn stuff, and there are 28 of them, and I finalized all of them except for one. And today we are going to finish that one: scan code for vulnerabilities in Azure Pipelines. And but that's a 1 hour 43-minute module, and let's see how we can get through that. And then in that case, I have 28. Let me quickly check my profile. Achievements. 28 badges. And as a bonus, I got 3 trophies. Let me copy the link for the leaderboard and the links. Put it in the chat over here. I should do it in the other one so people at YouTube have the same information. So now you get a duplicate in Twitch, but that's not a problem. So you can. So what are we going to do today? We are going to do the DevOps scan code for vulnerabilities in Azure Pipelines, and let me share that link with you as well. That's this one. If you hit the Bang project, there's the link as well, including a small introduction. So you can follow along if you just open the link, and then you can see what's going on. What do we need in here? DevOps, Space Studio, .NET Core, Git, GitHub, Sonar Cloud. What the hell is Sonar Cloud? Sonar Cloud. Clean code rockstar status. Never heard of that. Okay, let's start with this. Skip the Sonar Cloud, we'll probably run into that later on. Close the achievements, continue. Implement secure development process. There's a lot of storytelling here. It's important that your code doesn't open the door to an attacker, and a vulnerability that's exploitable in your codebase is an operations nightmare. In this part, you'll learn about vulnerabilities found in space game code. You see how the team plans to make sure that the vulnerability doesn't happen again. Let's check in on the discussion. What happens when a vulnerability is found? Tim finds Andy and Mara talking in the break room. Andy, do you have a minute? We have a talk. We need a talk. Sure. You've been a hard guy to locate today, Tim. I've been hearing about some issue with the game code. Is that what it's about? You got it. Someone found a code vulnerability in the space game code last night. We've been code red in operations and development all day. We think we've patched it up, but it's causing quite a stir among the leadership teams. They've brought in a consultant on the code security and integrity, and well, that's where you come in. Me? I didn't write any of the code. No, but I've been asked to with reporting on potential vulnerabilities on our entire code base. And that does include you. So I need to report the quality and safety to your teams. You need something with real numbers, concrete examples. That's a big request. I don't think we have any way to analyze your code easily. I saw something in the user group meeting. I went a few weeks ago. Go to the user group. Oh, user group meeting. So it's some user group meeting. I saved a document with some links. What tools or frameworks can we use? There are many tools, processes that we can analyze our code. You can evaluate each to find the one that best suits your kinds of software that you create. Here are a few. OWASP, OWASP, Open Web Assembly Security Project. Not for non-profit organization. Is a not-for-profit organization focused on improving the security of software. OWASP, OWASP hosts global and regional events with practitioners from all over all industries and can meet to share and learn the latest best practices around security management. OWASP also provides tools, code, and documentation to help practitioners understand the potential threats in the code and to take action. One notable project is the OWASP Top 10. Let's quickly have a look at that. Risks, injection, broken authentication, sensitive data, XML, broken access control. Well, a lot of risks over there. Top 10 list of critical security risks. The web application identified in the world's leading security experts. While there are hundreds of potential security risks out there, the top 10 details some of the most important and most common risks that many organizations can tackle first. You can see the OWASP Top 10 in action when you scan the Space Games project later in this module. Roslyn Analyzers. Roslyn refers to the .NET compiler platform. Roslyn Analyzers highlights potential problems in your code. Categories include code style, quality and maintainability, and design. You can run Roslyn Analyzers from VisStudio or from the command line. The following image shows an example of running the Roslyn Analyzers on Space Game web project from VisStudio. The variable X is declared but never used. Yeah. Okay. Sonar Cloud. That's where Sonar Clouds come in. By Sonar Clouds help you analyze the code for both vulnerabilities and code smells. A code smell refers to a code construct that, although it might be syntactically correct, can indicate a deeper problem within in how that code is designed or how easy it was to maintain. Code smells is subjective and can vary from one programming language to another. For example, many programming languages support the go-to statement as a way to control the flow of operations. Even if the go-to statements in the code are syntactically correct, using a lot of them can result in spaghetti code. Italian code. No, that's not nice to say. That's difficult for others to read and maintain. Constructs such as loops, return codes, exception handling are a few ways you might express go-to construct more clearly. Sonar Cloud works with programming languages like Java, C++, C#, and Python. Sonar Cloud provides tools that can analyze your code from the command line or your build pipeline. When analysis is complete, Sonar Cloud can upload the results so that that they are available from its web interface. Here's an example that shows the summary of analysis run on Space Game web project. Some blurry stuff and then the name. You can select the category to learn more about potential bugs or vulnerabilities the scan discovered. In this module, you run Sonar Cloud locally and then from Azure Pipelines. What are CWE, CVE, and CVSS? There are a few standard classifications that many security tools use. These classification systems help provide a common way for both people and tools to categorize and compare vulnerabilities impact. Here we'll discuss three important classification systems: CWE, CVE, and CVSS. CWE, Common Weakness Enumeration, is a list of common software security weaknesses and vulnerabilities maintained by the security community. For example, CWE 259. Let's click that. That's a lot of information. Hard-coded credentials relates to the use of hard-coded passwords in a source code. That's identified quickly. If the password becomes compromised, anyone who knows the password can access the system or service, such as a database or web server. Because the password is hard-coded, it can be difficult to update each installation that uses it after a security breach is discovered. Somewhat like the key that's used to encrypt CDs and DVDs. Once it was decrypted, then everything could be copied without too much issues. CVE, a list of cybersecurity vulnerabilities that's related to the common weakness enumeration, is a common vulnerabilities and exposures. Let's see what that looks like. Yeah. Okay. While the CWE defines security vulnerabilities in general sense, the CVE focuses on specific instances in software that generally is available. CVE commonly refers to security weakness that allows an attacker to compromise the system through techniques such as arbitrary code execution or buffer overflows. We won't call out any specific CVEs here, but they apply to the wide range of software that includes web browsers, databases, productivity software. When a CVE is discovered, it's the responsibility of the maintainer of the software to provide the user with a security patch. End user and administrators are responsible for installing that patch to help ensure they are no longer exposed to the threat. Like CWE, many tools scan for CVE recommendations. Common CVEs that development teams face relate to the use of open source components. When a scan reveals a CVE in your software, you and your team assess the risk and prioritize a fix. A fix might include updating to a new version of that open source component that doesn't contain the vulnerability, or possibly removing the component and providing its functionality in some other way. CVSS, also related to CWE and CVE, is the Common Vulnerability Scoring System, CVSS. CVSS is a scoring system of security vulnerabilities. The CVSS assigns a score from 0 to 10 to give a sense of severity of vulnerability. Vulnerabilities with higher scores are more severe than ones with lower scores. As an example, Shellstock was a vulnerability in the Unix bash shell that allowed an attacker to gain control of a vulnerability status. It was originally reported as CVE 2014-6271. The more general flaw is categorized as CWE 78 as command injection. You keep that in mind, remembering this numbering? I don't. Its CVSS score is 10, which indicates the highest severity. Vulnerability CVSS score isn't the only factor to consider, but it can help teams prioritize which issues to address first. What does the team choose? Do any of the tools work with our current build strategy? All of them do. It depends on when and where. For example, we can use Rosalind analyzers to find issues as we go. Rosalind analyzers can help identify and fix potential issues in our development environment before any potential issues make their way into Q&A in production. Tim says, I'm looking for something that will give me a report I can show to leadership. And Andy follows up with, in that case, let's try SonarCloud. SonarCloud gives you a report on your code base with the numbers and specific code lines that you're looking for. SonarCloud provides its own security rules, and it also reports issues from CWE and OWASP Top 10. It also works with a lot of different code languages. We can try it out locally first, and if it works for what we need, we can add it to our build pipeline. Amara says, I remember reading something about SonarCloud. I thought it was just for finding technical debt. What technical debt? Technical debt, whether deliberate or accidental, refers to the fast or poor choices made up front that require significant time to fix later. For example, when pressured for time, it's easy to let the proof concept become production code. If the proof concept isn't designed well, it can cause extra work when we want to add new features later. And he says, yes, SonarCloud can help us maintain our technical debt. The demo I saw, I used it as a part of Azure Pipelines so that scans are done on a regular basis. The presenter called it shifting left. That's what this dude over here also mentioned in the last videos. Because scans are done early in development cycle, let's go with this one and see what we find. If it helps, gets the report we need, I'm all for it. I can see this being nearly impossible otherwise. How do you handle security in DevOps world? Tailspin team has identified some of the tools and scoring systems that they can use to identify potential vulnerabilities in their code. But how do these tools fit into the DevOps world? In this short video, Abel Wang, cloud advocate at Microsoft, explains how.
How do you handle security in a DevOps world? Just like with quality, security is absolutely vital, right? And with the advent of our CI/CD pipelines, we're able to take changes and ship them all the way out into production extremely quickly. So how do we maintain security? If you think about how we did that before, we would have all these manual checks. I mean, basically, we tried to tack on security after the fact, right? We would build our application, and when it's all done, we would have people go do security checks, do security audits, and try to figure it out, make sure everything is all secure before we actually deployed it. But just like with quality, the problem with this is it takes an extreme amount of time to be able to do something like that. You know, maybe weeks to do a full security audit and a security check. And again, if we're deploying our code every time we check in, or even if we're deploying our code once every 2 weeks, no one has the time for all of that extensive security checks. So how do we maintain security? So just like with quality, we have to shift left and put more of the onus of the security checks onto the hands of our developers. Where now, every time we check in code, part of the pull request, which is like a code review process, not only should we check and make sure, oh, our code does what we think it's supposed to do, but the security teams need to be part of this as well. So they're looking at the code, looking for security problems as well. The other thing that you can do is you can build security checks into your CI/CD pipelines as well. So during your builds, you can do security scans to make sure you don't have creds in your, or deployed in your source control system. Or maybe you can have security scans that looks for security holes or things like that. So security, still incredibly important, even more important than ever. But instead of tacking it on after the fact, you need to build it into your process for your devs and also into your CI/CD pipelines.
Cool. The importance of a security development strategy is now commonplace that security for applications is extremely important. News services frequently carry stories about some companies' systems that have been breached and private company and customer data was stolen. So what are the issues to think about when you're planning a security development strategy? Clearly, we need to protect information from being disclosed to people that should not have access to it. But more importantly than that, we need to ensure that the information isn't improperly altered or destroyed. And it is actually destroyed when it isn't supposed to be. We need to make sure that properly authenticate who is accessing the data and that they have the correct permissions to do so. Through historical or archival data or logs, we need to be able to find evidence when something has gone wrong. There are many aspects to building and deploying secure applications. The first is general knowledge problem. Many developers and other staff members assume they understand security, but they don't. Cybersecurity is constantly evolving discipline. A program of ongoing education and training is essential. Second, we need to ensure that the code is created correctly and securely implements the required features. We also need to make sure that the features were designed with security in mind and in first place. Third, we need to ensure that the application complies with rules and regulations that it's required to meet. We have to test for compliance while building the code and retest periodically, even after deployment. Security isn't something you just can add to an application or system later. Security development must be part of every stage of the software development lifecycle. This is even more important for critical applications and those that process sensitive and highly confidential information. Application security concepts haven't been a focus for developers in the past. Apart from the education and training issues, it's because their organizations have emphasized fast development of features. With the introduction of DevOps practices, however, security testing is much easier to integrate into the pipeline rather than being a task performed by security specialists. Security testing should be part of the day-to-day delivery process. Overall, when the time for rework is taken into account, adding security to your DevOps practices can actually reduce the overall time it takes to develop quality software. Check your knowledge. How can you make sure your code isn't exploitable? Make every code construct private, never run SQL queries, or scan your code regularly for known vulnerabilities. I'd say the third one. What is the OWASP top 10? The top critical security risks to the web applications, the top critical security risk for Ruby, the top critical security risk for all types of applications. I'd say for web applications. Correct. Open web application. Which of these examples is an example of CVE? Buffer overruns in specific piece of web server software, access of an uninitialized pointer, or a severity score of 9. I think it was a list. The other one, CWE, is the top list. CVE. It's just a dictionary. I'd say severity score of 9. No, that's CVSS. So then it must be this one. Yes. Exercise. Set up your Azure DevOps environment. That's what we already did. At least we have to generate and run a new template to be prepared. In this part, you make sure that the Microsoft Azure DevOps organization is set up completely to complete the rest of the module. Set up Azure DevOps, work items, and blah blah blah. You create all this stuff, and you have to copy this link, otherwise might open in a different environment. Sign in. Now I have to approve. MLPU7 approve. There we go. Let's put this to the side and this to the other side. Sign in, create a new project. Space Game Web Sonar Cloud. Copy. Select organization. And this is the template for the thingy. Select the template includes a GitHub repository. Yes. Authorize. Let's quickly do this behind the screens. Copy. Sign in. Oops. Still logging in. Sign in. Authentication. Let's return to screen. I can do this here as well. Okay, authenticated. Create project. This will prepare the DevOps environment and build a work items board, like the Kanban thing. Navigate to projects. Yeah. Let's open DevOps. There we are. Important, the cleanup for Azure DevOps environment. That's what we need to do at the end. Project visibility, we'll keep it all public. Remove the work items to doing. Let's open this and go to the boards. Boards. What are we doing? Move the work item to doing. In practice, your team assigns work items, assigned blah blah. Which one do I need to move? Here you move the fourth item. Check for vulnerabilities to doing. Check for vulnerabilities. This one. To doing. And it should put my name on it. Like this. Call the check for vulnerabilities relates to examining the code base, find vulnerabilities and maintainability issues. Will likely add time to the maintenance of your code. Description: scan our code for vulnerabilities and code smells. Yeah, that's also in there. To set up the work item, from Azure DevOps, go to boards and then select boards. That's what we already did. That's already done. Set up the project locally. Here load the game project for Visual Studio Code. Configure Git. If you already set up with the MS Learn Tailspin Space Game Web project locally, you can move to the next section. Let's check. Projects. Maybe on the repos. Don't think so. No. Let's see. Yeah, we already set up Git. The Tailspin Game Web. That's this one. Clone or download. Copy. Is it copy? I think so. New folder. MS Learn. Tailspin. Space Game Web. I think this is a very old thing that I remember from TechEd. Here we go. Git clone. Something like this. Oh, now it's probably creating another folder inside this folder. Yes. So let's rename this. And cut this out. There you go. Okay. This is what we all did. Configure Git. Set up the project in Visual Studio Code. Fork locally. Fork locally? Clone. Clone my fork. Oh. I think I had this clone. Let's quickly go back. You load the space game. I think I already cloned this one. Trees. There you are. So let's remove this again. And go back to the description. This is installing Bash and installing Git. Already done. Set up your project. Visual code. Clone your fork locally. Go to your fork of the space game. And that's this one. Let's take this away. Clone or download. Let's clone or download. Copy. Visual code. Go to terminal. Well, I can do this just about here. Git clone and get back to the story. Clone in here. Code dot. Everything's opening in the wrong window. Terminal. Git remote V, it's already done, I think. Git remote V, yeah. Git remote add upstream, copy. Copy. Now it's the upstream. Open the project in File Explorer. On the File menu, open. Navigate to the root directory, space, it's already done. Continue. Scan the project locally by Sonar Cloud. Create a project on Sonar Cloud. Go to the from the browser tab, go to Sonar Cloud. Let's sign in using your GitHub account. Okay. Log in. GitHub. View your account, resource actions, and the email address. Red. Authorize. Let's bring it side by side. In the upper corner, select plus. There's no plus in here. And then select analyze this new project. Analyze new project. There's a plus. Analyze new project. If your organization is not filled in automatically, import another organization. Choose an organization. My own. Choose an organization, find the name of the GitHub account. That's mine. Only select repositories. And select the MS Learn. MS Learn, yeah. Select install to install Solo Cloud in this repository. Install. GitHub password. Key. Up to 255 characters. Create an organization. Organization is a space where the team of a whole company can collaborate across many. What's it saying in the documentation? Create a key for a unique name. Example space game 333. Copy. Already taken. Let's make that 1620 then. Maybe make that 200601. And select additional info. Display name. Fill it with the same text as the key. Select continue. Choose plan, select free plan. Create organization. Create organization. Organization is space where the team or whole company, blah, blah. Space, something. Description. All members for GitHub organization will be added to the Sonar Cloud. Continue. That's what we did, huh? Set up your project for analysis. Analyze projects, select repositories, select MS Tailspin repo. Yeah, it's already selected. This one. Select setup. .2 lines will be ignored. Okay. What's your build technology? No, what is your operating system? It's not in there anywhere. We recommend using another analysis method. Drive a CI, circle CI with other CI tools manually. What's your build technology? Select other. I think it says other, like this. Yeah. What's your operating system? Other operating system, Windows. Download. Is that Windows, by the way? Yeah. Under execute scanner from your computer, see sample sonar scanner command. Download and unzip the sonar scanner for Windows. Open file. Extract files. Okay. Sonar. There. Copy the data projects. So this is the bin folder. Notepad. You have to add that to path accordingly to the text. Let me check. Set path command. Something like this. Copy. Copy. Set. Oops. Wow. Do something like Notepad, copy, copy. There's the thingy. Execute the sonar scanner in your project folder. Copy. cd ms learn. Oops. What's the issue? Unable to execute Sonar Cube. No, it's not done. Let's get back to the information. This is terrible. Let's go. Scan locally. Now's a good time to install the latest version of Java SE. Come on, guys. Analyze your project. Select setup. What's your technology? Under execute scanner from your computer, see an example. Copy that command, paste it somewhere easy to refer back later. Keep this browser tab open for later. You don't need to download the scanner and software. Oh. Darn it. Or any other commands later. We follow slightly different procedures so shortly. Okay. That could be a little bit more clear if you ask me. At this point your Sonar project is created for you. So sample, copy that command and paste it somewhere easy to refer back to you later. So this is not needed actually. And I also don't need to install the Sonar project. Delete. And that also means from the downloads. Sonar. What? Oh, never mind. I don't know where the Sonar was going. Where's the Sonar command? Clear. In here. No. It was this command. copy. Bring it over here. Keep this browser tab open. That's this one. This one. The example so we don't execute it really. From Visual Code, open an integrated terminal. Run the following git command. Fetch a branch named security scan. Copy. As you did in previous model, format the format of this command enables you to get started, known as upstream. You shortly push this branch into your GitHub repository known as origin. As an optional step, open Azure Pipelines YAML and familiarize that we already did in previous sessions. Configuration resembles the one created in the run quality test in your build pipelines. Scan locally. Here you set up Sonar Cloud Scanner and scan your code locally. Then you upload the scan data to Sonar Cloud so you can analyze the results. The Sonar Cloud Scanner runs Java code during the scanning process. You start by making sure your environment is set up to run Java code. The latest version of Java SE. Installation. So which one do we install? Let's check. Wait, I don't already have. Java. Come on. This one. That's a very old one, I think. Installation instructions. JDK installation. Thank you for downloading blah blah blah. Windows. License. Who would have thought that I would be installing Java on my screen or machine? Okay. Yes, I was afraid of that. Now it's messing up my screen. Yes, now I have to update my screen again. This one. Because now you don't see my screen updating anymore. Change. Local desktop. I guess it's the second one. Let's see if it's updating. Yes. Back to the coding window. So now you should be seeing this, yes. In the meantime, it's showing me this. Install. Close. So hopefully it's enough for this to work. From the IDE, check whether the JavaScript home variable is set. Let's close this. Control tick. Echo Java home copy. Yes. 8. That sounds like old. Let's open a new one. Okay. That's doing something completely different. Back to the exercise. If the command doesn't output the path, you need to set and export its variable. To do so, you need to locate program files. Let's see, program files. x86, really? Java. Thought I installed the thing in here, yes. This is the most recent one. Copy. Let's remember this. Now we need to adjust this apparently. Copy. Make that like this. Copy. Copy. Here's on Windows, here's on Mac OS, Linux. More information how it sets variable on Windows. Let's try again. Echo Java Home. That should be better. Think. .NET Tool Copy. Install global.NET Sonar Scanner. You can invoke the tool using the following command: .NET Scanner Sonar Scanner. There are a few ways to install Sonar Scanner using .NET Sonar Scanner is an easy way to scan .NET Core code. Refer to your Sonar Scanner command you copied earlier. Here's an example. These values to blah blah blah, Sonar project key, organization login. From the terminal, create these. Do we need to run this? Apparently not. Okay. Copy. Your Sonar Cloud project key. That's this one. Apparently. Organization. Login. Copy. Let's see, run the following command. So we need to run this. I think so. Copy. Copy. Not sure if I need to do this one by one, but better safe than sorry. Now next to the following thing, run the .NET Scanner begin command to prepare the scanner. Copy. If the command fails, try it running like this. I think I need to this one because the other one failed as well. That's failing. Copy. I think that works better. That did something. This command uses the information you stored in variables and the information to help the scanner. Project, the URL, the login, report path. In run quality tests in your pipeline, you analyze the amount of code covered by unit tests. So Sonar Cloud can also display the coverage. The Sonar Cloud Sonar CS Open Cover report path specified where you can find the code coverage information. Run this .NET build command. Copy. .NET build no incremental configuration and release. What? Warning. It's a warning. This is also a warning. all kinds of warnings. You see more warnings than usual because Sonar Scanner modified the build process to be able to scan your code. Run this .NET test command to run the unit tests and collect code coverage results. Copy. That's wrong. Again, we need to take the second one. Command varies slightly from the one that you used in the previous module. Previously you used coverlet output cobertura, collect code coverage. Sonar Cloud needs the results to be in open cover format. This version of the command output code coverage results in both formats. See a cobertura and we have an open cover. %, 100%, average 888. The percentage C part represents a comma character and makes it easier for the command to parse a string. Run the .NET Sonar Scanner and command to complete the scanning session and upload the results to Sonar Cloud. Copy. Unrecognized command. Again, we need the second one. Come on, guys. There we go. Quality profile. Warnings. Let's see, denied. Yeah. Oops. Get a security alert on the other screen. Analysis successful. Almost a minute. Final memory 31 max. Examine the results. Wait for the scan to finish. From a web browser, go to the Sonar Cloud project. If you close the browser, go to Sonar Cloud something. I didn't close it, I think. This one. What do we need to do there? There's several categories. My projects. There it is. So you see the results of your scan. There are several categories you can examine. Start with reliability at the top. If you have bugs, they show up here. We have 2 bugs. Select it to see more details. 2 bugs. There are 2 bugs. And how do we access that? Click it. Replace this B tag by strong. That's the bold tag. Why is this an issue? The strong B and EM and I tags have exactly the same effect in most web browsers, but there is a fundamental difference between strong and EM. We have semantic meaning where B and I only convey styling information like CSS. Okay. You can select C rule to learn more about it. That's what I just did. Well, not C rule. So why is this an issue these days? In practice, your team assesses each bug and prioritizes where it fixes. The bug is categorized minor. It's minor, but the other one is major. Add lang or xlang attributes to HTML element. As an optional step, return an overview tab and explore the results from other categories. For example, the security section, you can examine reported vulnerabilities. Maintainability section provides an estimate of your technical depth and the code coverage. Let's go back. Security 0 to security hotspots. Make sure that command line arguments are used safely here. Make sure the debug feature is deactivated before delivering the code in production. Maintainability 1H. What does it mean? "11 code smells. Make this field private." Is major. Add protected constructor to static or static to the class declaration. Okay. I was a bit nervous, but the results aren't that bad. It doesn't look like we have a major security issue, but we have some technical depth in there. Now that we understand the process, we can add add it to the build pipeline. That way we can scan the code on a regular basis. As we resolve the reported issues, the results will improve. Anyone with access can sign in and see the latest report whenever they need to. Let's see how that works. Remove intermediate file recall. When you ran .NET Sonar Scanner earlier, the process created a number of intermediate files in the Sonar Q folder. These files aren't intended to be included in source control and you no longer need them, although the project git ignore is already set up. And to ignore anything in Sonar Cube, it's a good idea to delete the files. So you so they are not added to Git. Copy and delete. Done, I think. Next exercise. Scan from a build pipeline using Sonar Cloud. Only on 5 of 9. We are already an hour and 20 minutes in. This part you add a task Azure Pipelines, install the Marketplace extension. From a new browser tab, go to marketplacefishstudio.com. Copy link and go to this one. Because this one should be on the Azure DevOps tab, search for Sonar Cloud, Azure DevOps, Sonar Cloud. Select Sonar Cloud from the results, this one. There's a checkbox. Select get it free. Other organization. Install. Install. Create Sonar Cloud service connection. Your pipeline tasks require an access to the Sonar Cloud. Here you create a service connection from the Microsoft Azure DevOps portal. A service connection provides secure access to an external service such as Sonar Cloud or Azure. From Azure DevOps, navigate to your project. Select project settings in the lower corner. Let's do this side by side again. No. It should be this one. Project settings. The pipelines. Select service connections. Select project settings. Under pipelines, select service connections. There. Then select Sonar Cloud. New service connection. Sonar Cloud. Next. Sonar Cloud token is the token that you worked with the previous. Sonar Cloud token. So which one is the token? Connection name. Which one is the token? The login token maybe? Authentication token. Go to my account security, generate tokens. I think it's this one. Yeah, verification succeeded. You can print your Sonar login bash variable if you need to get this value. I don't think so. Verify and save. Yeah. Create pipeline variables. You're almost ready to add pipeline tasks to your pipeline configuration. First, you add a few variables to your pipeline. Recall the Sonar Cloud Marketplace extension provided a built-in task to perform the first task you use, named Sonar Cloud Prepare 1, requires some information specific for your Sonar Cloud project, such as the project name and project key. Although you can add these variables to your Azure Pipelines, here you add them directly to the Azure Pipelines to make your configuration more reusable. Let's add a few variables to the pipeline. From Azure DevOps, navigate to your pipeline and select Edit. Pipelines. Select pipeline. Edit. Where is it? Select variables at the top right. variables. New variable. In the dialog box, set the name to Sonar key project key. Copy. And the value is the space web. Project key. Copy. Add value to project. You can print your Sonar project key if you need a refresher. Notice keep this value a secret option. Notice the keep this secret. If you select the option, the value of your variable will be encrypted when it's standing still. It's a good way to store secrets like tokens, but you don't need that to do that here. Okay. Create another variable and name it Sonar project name. So this is okay. Create a new one. Plus Sonar project name. No, Sonar organization. Should be Sonar organization, I think. No. Set the name to Sonar project key. Sonar project name. It is Sonar project name. Oh, the other one was the key. Yeah, it was. Sonar name. Is that the organization? No. Same project name as its value. Okay. So this is exactly the same. Copy. Apparently. Okay. Then Sonar organization. Copied earlier. So that's this one. Copy. Okay. Let's check. Project name, project key, and the organization. Now save. Add task to the pipeline. Here you add a task that perform the scan to Azure Pipelines. Recall that you scanned locally. You used .NET Scanner tool. Here's the .NET Scanner begins command that you run to prepare the scanner. You don't need to run this right now. Although you could run this same command in the build pipeline, you would need to secure the access to the Sonar login, which defines your access token. An easy way to build is to use these built-in tasks. Task types provided by the Sonar Cloud extension. Sonar Cloud 1 maps to the begin, the other two to the end. From VStudio, open Azure Pipelines and replace it with contents with this code. Copy. Need to go to here. YAML pipelines. Control A, del paste. Save. So this now should have use.NET 2 difference. This one. And the last part. Build stuff. So cloud analyze. Face is really white. I need to put in a backlight. Oops. That's better, I think. Oops. To trick the camera into doing the right thing. Slight delay in there. That's it. Let's see. Notice that the Sonar Cloud appears before the project is built or tested. As a run, similarly, Sonar Cloud analysis and publish appear after the project is built. A lot of changes. Same process you used to when you're scanning locally from the command line. Also notice the Sonar Cloud Prepare 1 contains information specific to your account and uses the pipeline variables you created a moment ago. You may have noticed the additional use.NET which specifies .NET version 2.1 at the time of writing Sonar Cloud for pipelines need .NET 2.1 installed. Copy. This is the specific parts. Let's go back here. There. It's this part. What's Azure Pipelines build the application? Here you push your changes to GitHub and see the pipelines run. Save. Git add pipelines, commit, and run push security scan. Oops. Yeah, that's still the same error with the GitHub issue. Let's quickly go over to the website, pipelines. It's running. The job is running. Wiring. There it goes. use.NET Core 3.1, that's for the project. .NET 2.1, that's for Sonar Cloud. And install. Let's go back to the instructions while it's running. Analyze results. Return to the Sonar Cloud portal, refresh the page, and then examine the results. You'll see the same results as you've scanned locally, but because the project haven't changed, as you resolve the issues from the project and add new features of the application, your project changes over time. Issues you resolve are removed from the report. Likewise, new issues might appear as you add features, or security community provides new recommendations, and the Amara discussed the progress over lunch. I'm glad we're able to help Tim prepare this report for the security consultant. It would have been much more difficult if we didn't have an automated way to understand potential vulnerabilities. And he says, I agree, our DevOps investment is paying off. We also bring this report to leadership. If the high severity vulnerabilities appears, or we find we have too much technical debt, we can use the report to justify spending time to resolve them before adding new features. Often new features can wait when security is high priority. Rethinking application config data. Now that we have seen how to detect vulnerabilities within the pipeline, let's think about general ways to think about one of the most common attributes of an application, its configuration data. An important rule to follow is to separate concerns. One of the key reasons we want to move the configuration configuration away from source control is to delineate responsibilities. Let's define some roles. Configuration custodian, responsible for generating and maintaining the lifecycle configuration values. These include CRUD on keys, ensuring the security of secrets, regeneration of keys and tokens, defining configuration settings such as log levels for each environment. These roles can be owned by operations engineers and security engineers, while injecting configuration files through proper DevOps processes and CI/CD implementation. Note that they do not define the actual configuration, but are custodians of their management. Configuration consumer, responsible for defining the schema for the configuration that needs to be in place, and then consuming the configuration values in the application or library code. Development and test teams should not be concerned about what the value of the keys are, rather than their concern is what the capability of the key is. For example, a developer needs different connection strings of variables in the application, but does not need to know the actual value across the different environments. Configuration store, the underlying store that holds the configuration. This can be a simple file, but in distributed application, it needs to be a reliable store that can work across environments. The store is responsible for persisting values that modify the behavior of the application per environment, but doesn't contain sensitive information and doesn't require any encryption or hardware security modules. Secret store. While you can store configuration and secrets together, it violates the separation of concern principle. So the recommendation is to use a separate store for persisting secrets. This allows a secure channel for sensitive configuration data, such as connection strings, enables the operations team to have credentials, certificate, and tokens in one repository, and minimizes the security risk in case the configuration store gets compromised. Next exercise, limit scanning to pull requests. Continue. Only 6 of 9, and we are already in 1 hour and 40 minutes. Let's quickly see if the job is completed. Yes. So now we have to go to the Sonar Cloud site. This one. Go back to my projects. We now have update, I think. And it's still the same. Get project badges. Okay. There's no change because the code is not changed. Back to the program. Limit scanning to pull requests. At this point, your build configuration scans your code when a change is pushed into the repository, but you might have noticed that the scanning process adds time to overall build process. You don't want to scan on every small commit. Instead, you want to scan less often, such as on pull requests only. You can use conditions in your pipeline to accomplish this. In this part, you modify your build configuration to run Sonar Cloud Scanner only when the build is happening in response to a pull request. Scanning our code in pipeline is great, but look how much time is added. Well, it's only a minute. That's true, but it adds up. We want to get feedback on our builds as quickly as possible, plus the time will increase as we add more code and there's more to analyze. Fair point, says Mara. We don't need to run these checks on every build, but it's important that we validate changes before we merge them into master. I believe there's a way we can conditionally run the scans, perhaps when there's a pull request. That's what I was thinking. Let's try. What are conditions? In pipeline, Azure Pipelines condition enables you to run task or job based on the state of the pipeline. Some of the conditions you can specify only when the previous dependent task has succeeded, even if the previous dependency has failed, unless almost cancelled, even if previous dependency has failed, even if the run was cancelled, only when previous dependency has failed, or some custom conditions. Here's a basic example. Steps, script hello echo, condition always. This will always say hello conditionally. This will say hello unconditionally, even if the previous task failed. Here's a condition that's used if you don't specify one. Then it's succeeded. Succeeded built-in function checks whether the previous task succeeded. If the previous task failed, the subsequent task will, with the same condition, are skipped. Here you want to build a condition that specifies the previous task succeeded, the build is for a pull request, and the pull request is against the master branch. To get a build reason, you use the build-in build reason variable. This variable is set to pull request when the build is for a pull request. To get the target branch for the pull request, you use the built-in system pull request target branch variable. Here you want to check whether the variable is set to master. There's a few ways to access the variables within the condition. Here you use variable syntax. To test the variable value, you can use the built-in equal function. This function checks whether the arguments are equal. With that in mind, here's a condition you apply to build tasks that relate to scanning used Sonar Cloud. Condition and succeeded equals variable reason is pull request and master. The first condition, the end checks whether the previous one succeeded. Second one, if it's a pull request, and the third one, if it's against the master. In YAML, you use the pipe syntax to define the string that spans multiple lines. If you could define the condition on a single line, but we write it in this way for more readable reasons, refer to your master branch to the original state. In other modules, you merge code to master. That might not be compatible with the changes you make here. For learning purposes, here you ensure that the reason that your repository master branch on GitHub is in its original state. This step is not typical, but it ensures the pull request. You also remove the branch protection rule that you set up on the implement code workflow in your build pipeline GitHub module. To delete the branch protection rule in GitHub, go to your Space Game project repository. So we need to go to GitHub. Where did I leave my GitHub item? Here. What do we need to do there? In GitHub, go to your Space Game project repository. Here. Select settings. Yeah. On the menu, select branches. Yeah. Under branch protection rule, locate the name rule master. Branch protection rule master. If you don't have this rule, you can skip the next step. Select delete, the rule is deleted. Delete. No warning. In Visual Studio Code, go to the integrated terminal and run these commands. Where's my code? Here. Oh, wait. Failed to resolve upstream master as a valid revision. This resets your master branch to the master to match the one provided in Microsoft version of this repository. It's a valid revision. Still get this one. Scan only pull requests to the master branch. In this part, provide a condition to each build task that relates to Sonar Cloud. This condition limits scans to only when the build is for a pull request in the master branch. From Visual Studio, modify it like this. Copy. This one. Nope. Save. Interesting. It adds the condition of the YAML file. This one. There's a condition. From the integrated terminal, add Azure Pipelines YAML to the index. Copy. Git commit. One file change. Need to fix the GitHub error after stream or something. Not sure what it is. This is what we did. As an optional step, go to your Azure Pipelines and trace the build as it runs. It should now be running again. Pipelines. It's now running again. Oh. There's warnings. It's not really running, I think. You see the scanning task that relates is now skipped. Actually, it didn't do anything, I think. Just to the code, go to the integrate terminal and run these commands. Check out master. It's 15 minutes ago, that's a longer time ago, so it did not trigger at all. Already on master. Failed to resolve upstream masters of a revision. What does this do? Git reset. Unstage a file while retaining the changes in the working directory. Let's Google this. Failed to resolve upstream master as a valid revision. Apparently it's not the only one. To resolve doesn't show. Revision. As a valid, this one. Perform the below git commands. Git checkout master. That's already done. Git checkout master. Git pull upstream master. Git pull upstream master. Then git reset. Delete all the changes for your fork master. Git. Let's go to instructions. Where is it? Git push F. Copy. Yeah, that's the same. Yeah. Now go back to the documentation. The other one. Where did it go? This one, yeah. Copy everything. YAML. Azure Pipelines deleted. Did I now everything gone? Azure Pipelines. Force push changes, you do so here to reset the state of your GitHub repository. If in practice there are safe ways to revert changes through Git. This part you provide a condition to each build task that relates to Sonar Cloud. I think I just messed things up because I don't see any of the change anymore. Okay. Raise pull request against the master. Okay. Let's find Azure Pipelines. Quickly go to GitHub. That's not GitHub. This one. Where is the YAML file? Go back, I think, first. Let's quickly go back. To find where the thing is. Already done. Continue. Scan locally. Where's the YAML file? Continue. Where's my Azure file? Azure Pipelines file. It's not in there anymore. So let's get back to delete all this. See data projects. So it's E. Delete this one. Go back to here. To mine. Browse evil in master, clear clone download. Copy. Git clone. cd ms learn. Okay. Probably messed it up. Let's see. Meet the team, it's already done. Person analyzers. Not to read. Set up your DevOps. Select a fork repository on GitHub. Navigate the project. Doing. Set up locally. Let's do this again. Create project. Oh. Oops. Oh, in that case, I need to delete the project. That's indeed the case. Here. Space web. Just delete the project. Oops. Copy. Delete. That's gone. Do it again. Completely redoing my thing again. Create it. Navigate to project. There it is again. Go to the instructions again. Done. Move the work. Bought. Check vulnerabilities. That's mine. It's me. Save. Set up locally. Done. Go to your fork. This one. Copy. Deleting it again. Git clone. Yeah. Where's the instruction? Git clone. Go to the thing again. Let's learn. Clones, which we did. Git remote. You see that both that's what we saw. Git remote add upstream. Copy. Well, I can just rerun it. Now we have 4. Code. Open it, continue. Solar Cloud is what we already did. Set up your project for analysis. That's what we did. Fetch the browse from GitHub. Copy. Tick. Paste. Now we get the Emerald pipelines back. Scan locally. I believe all that. Oh, we have to do something there. Scan locally. We have to check Java. Echo. Copy. That's the old one. Copy. Yeah. Second time always goes a lot faster. Here's example Mac, Linux. Run the following tool. Copy. Okay. Okay, yeah, it's global. Refer to, here's an example. This example, the default values. Replace the placeholder values with yours. Copy. Run the following thing. Copy. That's not working, so we need the second one again. Running. So what we all did. .NET run .NET build. Copy. Run this .NET test command. See more warnings than usual. That's because some scanner blah blah blah. That's what we did. We have to test things. Is it already done? Yes. Second one. Yeah. Run the .NET's this one. Examine results. I think that's still open somewhere. Back to this one. Sonar Cloud. Still open. 10:47. What's the time now? Yeah, 10:48. Okay. Optional tab to watch all these items. Remove intermediate files. Copy. Done. Continue. Install Marketplace extension. I think I already had that. Get it free. Create Sonar Cloud service connection. Navigate to your project. This one. Project settings. Pipelines. Service connection. New connection. Sonar. Still available. Sonar Cloud token. It's a login token. Secrets. It's okay. It's hiding it. Connection name. Copy. Need to verify this. Verify is safe. From Azure DevOps, navigate to your pipeline and select Edit. Edit, variables, new variable. Oops. An error occurred while fetching the YAML files in repository default branch and latest master. Error on last attempt. what's this? Scan locally. Some results. Error occurred while fetching YAML file Azure Pipelines YAML in repository default branch and latest build branch master. Enhance this pipeline by changing its connection to the Azure Pipelines GitHub app. Let's see. I think I missed that one. This is done. Create a Sonar Cloud Service connection. That's done. Create pipeline variables, but it's not allowing to. Where's my DevOps? Overview. Settings. Come on, guys. From the navigated pipeline, select edit. What if I just push this in? Copy. Save. Oh. New variables. This one. No. This one. Copy. That needs to be like this. Copy. Okay. Then so project name. Copy. Okay. Copy. No. Create. Organization should be this one. Okay. Save. So here's the Azure Pipeline GitHub app. No. It's not finding it. Azure Pipelines, YAML. Question is, where's my YAML thingy in here? to bring it in from origin, I think. Let's see if I can get by. Continue. Oh, okay, I need to finish this. I completely need to redo this. Okay, let's wrap this up for now. I will redo this because I somehow messed up my thingy. Yeah, so I actually need to rebuild it, and but I'm doing this off stream. I think that's a better option for now. Let's wrap it up and see you next time. Bye bye.